Hello everybody, welcome to Dark Dragon Does Math. This is my first video for the 2017-2018 year, and it's 7th grade! That's right guys, I've been moved up. If that is good news, well great. If it's bad news, we're going to make it good news. Alright, so I'm going to jump right into this, and yeah, let's get to do some math. We're starting with Chapter 1.1, representing rational numbers on the number line. Let's get through some vocab first. We have integers. These are numbers that can be written without a fractional component. Without a fractional component. So, for example, 21, 4, 0, 2048, these are all integers. Technically, the negative version is, but I have a separate thing. Negative integers are just integers less than 0. So, integers less than 0, for example, negative 21, negative 4, and negative 2048. Notice 0 was not included. 0 it represents nothing. It is neither positive nor negative, so that's why it's not included in the negative numbers, because this is negatives less than 0. Less than does not include. Rational numbers are any numbers that can be expressed as a fraction. Look at that. So any number that can be expressed as a fraction. Think of it as a ratio, rational. I don't know if that helps, but expressed as a fraction. So for example, you could have 3/4. You could have 1/3. You could have 5/2. Even though that is an improper fraction, it's still a rational number because it is an integer over an integer. You could even get into negative numbers, like negative 3 is a rational number because it could be represented as negative 3 over 1. So these are examples of rational numbers. And then absolute value is just the distance a number is from 0. So the distance a number is from 0. That's going to be the absolute value of it. So, for example, the absolute value of 3 is 3. The absolute value of negative 3 is also 3, because distance is never negative. You could run a 2-mile race in any direction, and you're always going to say I ran 2 miles. You'll never say I ran negative 2 miles or I this or that. Distance is always positive. So it's not like you can go in reverse on your car and it takes miles off of your engine. So you're just adding wear and tear with whichever direction you go. If I want to find the absolute value of negative 11/12, okay, if I want to find the absolute value of that, remember, it's literally just making the number positive. Very simple. If I want to find the absolute value of 26/15, also, it's positive to begin with, but we act like we've done something to it, and we just rewrite it. It's 26/15. No matter what, it's positive. It's the distance from 0. I guess if you really wanted to, you can make this an improper fraction. Not improper, a mixed number. You could say, okay, 15 goes into 26 one time. If we subtract 15 from 26, we're left with 11. So 26/15 is the same thing as 1 and 11/15, which is important. So if we were to represent both these numbers on a number line, which number is closer to 0? So if I want to represent both these numbers on a number line, I want to make sure my number line is nice and symmetrical. So let's start with negative 11 twelfths. So it's negative. It's going to go in the negative number. It's not quite 1. It's, if this was negative 6 twelfths, which is half, negative 11 twelfths would be real close to there. And I don't have to be precise right now. So negative 11 twelfths would go right there. And if we were going to go this way, 26 over 15, which is, remember, 1 and 11 fifteenths. So let's say we broke this up into thirds, where this is 5 over 15, and this is 10 over 15. That means that 1 and 11 fifteenths is about right there. So let's think about distance from 0. Obviously, this one is much further away than that one. That's why if we were to say, okay, so which is greater, which is a common question in a math class, is what is greater? The absolute value of 26 over 15 or the absolute value of negative 11 over 12? Well, we can see as a number line or think, okay, so this is less than 1, this is more than 1, it's probably going to be the one that's more than 1. That one's greater. So anyways, there's that. Something I'm doing differently this year, which is I'm going to try to flip my classroom. So you'll notice on your notes that you have guided practice 1 and 2. This would be the time in the video that you would pause it and actually try these two on your own, and we'll go over them when I see you again, which would be the next class day. Hopefully, as long as you're not sick, but remember, absence is pile up. So anyways, so we watch these, or do these 2 videos on your own, pause the video, and then continue below. Alright, so we're going to do practice problems 4 through 8. Basically, we're taking each one of these numbers and we're going to write as a fraction m over n, where m and n are both integers. Basically, these are all rational numbers, and we're going to put them in the simplest form. So we have 23. Well, 23 is a gimme because 23 over 1, it's a whole number. Whole numbers are just that number over 1. Negative 45 would be negative 45 over 1. 11 and 7/9 is a little bit trickier. So I'm going to show you how to do this. Basically, if we want to make this, technically we're just making it into it. It's a mixed number now, we want to make it an improper fraction. You take the 9 and you keep it, so the denominator stays the same, and you're going to take that 9, you're going to multiply by this whole number, so 9 times 11, that's 99, and you're going to add it to whatever number is on top of the numerator. So 99 plus 7, well, that's 106 over 9, and we do it like that. And if we could simplify, we could. We can't simplify this because 9 and 3 do not go into 106. That's something you could check on your own. Negative 16 over 21 is actually the simplest it can go. It's already a fraction. Even though it's a negative, that's fine. So this is literally just negative 16 over 21. But this one, 24 over 10. Yeah, it is a fraction. It's an integer over an integer. But we can actually simplify it because 2 goes into both 24 and 10. So if I said 24 divided by 2, I'd have 12. 10 divided by 2 is 5. So that's switching, basically writing these numbers as rational numbers, rational number fractions. Pause the video, try 3 through 6 on your own. Now we have these, okay? So we are switching now decimals into rational fractions. All right, so here's my bet. We can think of this, okay, that's 4/10, right? So 4 over 10. Another way to think about it is however many numbers are behind the decimal here, you write that many numbers of zeros and behind 1. So for this one, there's 1 number behind the decimal, it's 1. And then you just simplify. Well, 4 goes into 10, 4 and 10 have 2 in common. Divided both by 2, we get 2/5. This one, well, it's negative. Whatever number is decimal it is, we're going to write that on top of our fraction, so 186. And below it, we write a 1 with however many decimals there are. So there's 3. 1, 2, 3. This is technically negative 186 thousandths. That's why there's a 1,000 on the bottom. So if you didn't know that, now you do. Simplify that. They're both divisible by 2. 18 divided by 2 is 9. 6 divided by 2 is 3. And let's keep that negative there. 1,000 divided by 2 is 500. 93 is a prime number. Anytime you get a prime number on the numerator, it's as simple as it goes. So we're done there. This one is a little tricky. We can do it multiple ways. I'm going to show you this one way and this one another. But so 30 and 30.5. A lot of us know that 0.5 is a half, but in case you didn't, we could say 30 and 5 over, there's one decimal, so 1, 0, 10. So the first thing I'm going to do is I'm going to simplify the fraction. So this is 35 goes into 10, 1 half. All right, so we have 30 and 1 half. And so now we're going to convert it like we did the problem earlier. We're going to write 2 on the bottom. 2 times 30 is 60, and then add the 1 on top. So 60 plus 1 is 61. This is 61 over 2. And we're done. Alternatively, and I'm going to do it this way, write this as if there was no decimals. So for this one, I would say 148 negative. On the bottom, still write, there's 2 zeros, so 100. It's actually just kind of skipping a step. I could have done this one here. I could write 305 over 10. And it's going to simplify the same way. Instead of dividing by 2, we're actually dividing by 5. 30 divided by 5 is 6. 5 divided by 5 is 1. 10 divided by 5 is 2. So on this one, I know that at least 2 goes into it. So 2 goes into 14 7 times. 2 goes into 8 4 times, so negative 74. 2 goes into 150. These are both still even, so I can actually simplify some more. I can say, all right, 74 divided by 2, that's going to be 37. 50 divided by 2 is 25. And now we're finished. So we've converted fractions into rational number fractions, and we've converted decimals into fractions. And as you can see on the back of this, we have more guided practice for you. So come to class with the 10 guided practice filled out, as well as your notes. I'll see you tomorrow. Have a good day. Wait, whoa, I can't forget math!